Now we will study the simplest motion in two dimension, which is usually termed as a half projectile. By half projectile we mean that the body which is being thrown horizontally from certain height. So we talk of that type of motion, a body being thrown horizontally from the top of the height. We take into consideration there is no horizontal acceleration, which confirms that there will be no change in horizontal velocity. But as the vertical acceleration due to gravity is there, the vertical velocity will keep on changing. At the topmost point from the top of the tower, when the motion is starting, there is no vertical velocity initially, and slowly vertical velocity will come into picture. Now let's say we have starting from, this is the height h from where the body is being thrown downwards. Ux is u, that is the initial horizontal velocity. You can see there is no vertical velocity over here, only and only horizontal velocity. And since there is no acceleration, the horizontal velocity, what we term as ux as u, will remain ux, u is equal to vx, will remain throughout the journey the same. At all the points we'll have the horizontal velocity to be same. But vertical velocity, you find over this point there is no vertical velocity. At this point it is again Vy is minus gt. Again using the formula V is equal to u plus at. The initial vertical velocity is 0 and the acceleration due to gravity is minus g. So it's minus gt, small time taken. Now as the time is progress, the length of the vector and hence the magnitude of the vector increases over here. So this is the minus gt at this point, and this is when it touches the ground. The body starts from here, horizontal velocity remains constant throughout the journey. The vertical velocity, which is initially 0, keeps on increasing, and when it touches the ground, this minus gt. It touches the ground, it makes an angle theta with the horizontal such that the horizontal is ux, u or vx, and the vertical is now minus gt. In this case, the time is the total time of flight. The distance from the point of through, the horizontal distance is termed as the horizontal range, which is at r. Or the horizontal distance is given as the range r. Now since there is no change in the horizontal velocity, the body would not change any direction, the horizontal direction, the vertical velocity will always be into the picture. Now we can see that since the horizontal velocity would not change, whatever is the horizontal velocity initially, it will remain the same. The second basic part is that the vertical velocity will keep on increasing because of acceleration due to gravity. So for the whole part of the journey, we can say that ux will remain equal to vx, and the uy, which is initially 0, will keep on changing and will be ultimately turning to vy, which is minus gt, which we write it over here. Now we have to cover the horizontal distance, the vertical distance on these grounds differently. The horizontal distance covered is r, the vertical is h. The vertical distance will be covered by the acceleration due to gravity g in certain time t. So initial vertical velocity being 0, we can use the formula s is equal to ut plus half at square, and in this expression the s will be minus h. The acceleration due to gravity would all be equal to minus g, and hence we get the equation as minus h is equal to minus half gt square. Since negative from both sides of equation is removed and we are ultimately left to find the time, so we increase the equation to a final simplification stage and we write it like this. So what we get over here is that the equation gives us the time of flight, which is under root of 2h upon g. Now we have got the time of the flight. The same time the body will move in the horizontal direction. The horizontal direction does not have any acceleration, hence the total distance covered will be only velocity into time. So there is no acceleration. We can use the formula that the distance is speed into time, and we come into picture r is equal to u into t, where u is the horizontal velocity, t we have just now calculated under root 2h upon g. Now, we know that the horizontal velocity would not change, vertical would keep on changing, and hence the net velocity will also keep on changing. And to get the final speed or the final value, we should know that the initial two components of the velocity, horizontal and vertical, are to be squared and added, and that comes into the formula. We know that horizontal square plus vertical square will give the final velocity, and hence we get the over here v is equal to ux square plus gt whole square. From this expression, it is very clear, as you increase the time, the speed would also increase and the vertical velocity would also increase, but the horizontal velocity would remain the same. Now, we are also left to find the final angle theta at which the body is going to strike at the ground. Now, when the body strikes the ground, you can see this is the angle theta, this is the horizontal, this is the vertical. So we talk of this angle theta. The tan theta would be obviously equal to perpendicular upon hypotenuse. In this case, you know the perpendicular will be gt and the horizontal will be ux. Hence, what we get over here is tan theta is ux upon t. Thank you.